Hello, everyone, and welcome to The Vertical Space, a podcast at the intersection of technology and flight. We are your hosts, Jim Barry, Peter Shannon, and Luka Tomjanovic, and here we look at the most important forces shaping the market of advanced air mobility with a particular focus on why and how they matter to those building a business in this very exciting and growing industry.
We're at a revolutionary point in aerospace. This technology of distributed electric propulsion systems and advanced flight control systems is revolutionary. And we must apply the evolutionary learnings that we have had over the last 120 years. And by doing so, in the thesis I lay out, you're helping to ground that base and think about, okay, let's not just run down the hill. Let's walk and make sure that we can cover all the aspects that we need to cover. Our air transportation industry is the safest mode of transportation in the world, and yet we still have some certainly surprises that occur in aviation safety, in the design of the vehicles, in the control systems. We've all seen them in recent times. And here, these are processes in aircraft that have been around for quite some time. So I just want to make sure that we stay grounded in that. We don't just accept the fact that we got this new technology and it's going to just work immediately and be safe because it's new tech. We've got to go through the processes and procedures and time of use to bring this to a scalable solution for transportation.
Welcome to a much anticipated return of David Stepanek, Executive Vice President, Chief Transformation Officer of Bristow. Few can offer a more seasoned, measured, practiced, realistic view of where advanced air mobility has been, is, and perhaps where it's going. For those who have taken a careful, realistic approach to advanced air mobility, this discussion is a confirmation of your smart approach. We've been so eager to have guests back for a second conversation because the earlier impressions and assumptions mature over time, and in some cases they hold true, and in others they evolve. Hearing how things have changed can be of great value to our listeners, OEMs, operators, as well as investors. We're particularly fortunate that David and team have taken the time to write a philosophical guide for early operations, as they have put their thoughts on paper on how advanced air mobility should be carefully and properly deployed. David and Bristow have been early adopters, buyers, and implementers of advanced air mobility, so their initial and subsequent assumptions and realized outcomes carry great weight. As David mentions often throughout the guide and our talk, he believes that those who have experience in vertical flight and being experienced operators have a particular edge in evaluating, deploying, and scaling advanced air mobility. So listen to David's summary of the guide, his 5-point thesis and general observations, his discussion of health management and flight operational data to enhance and optimize safety, and David's thoughts on what early advanced air mobility assumptions have proved out according to plan and what has changed from what some had thought just a few years ago. Given how prescient David and team were just a few years ago, perhaps we'll listen even more on how he views the future of advanced air mobility as well as its risks and opportunities. Additionally, perhaps we'll even be a bit more critical and circumspect of those who have an interest in an idea but don't really know how or don't have experience in bringing tech to the aviation market. Many thanks to David for his return visit and an important and engaging discussion. And to our guests, we hope you enjoy our talk with David Stepanek as you innovate and generate positive financial returns in the vertical space.
This episode of the Vertical Space podcast is brought to you by Avionics. Avionics is the leader in low size, weight, and power certified avionics for manned, unmanned, and advanced air mobility aircraft. Let Avionics help you achieve your goals, whether that be type certification, airspace access, or beyond visual line of sight operations. Avionics has certified and certifiable communications, navigation, and surveillance avionics for your aircraft. So head over to uavionics.com or Google it to see how you can start flying safer and move your platform forward into shared airspace.
David Stepanek became Bristow's Executive Vice President, Chief Transformation Officer in March 2021. In this role, David is leading the transformation of Bristow by introducing the next generation of advanced air mobility aircraft and expanding Bristow's core business in new regions. Through David's efforts, Bristow has forged strategic relationships with multiple advanced air mobility manufacturers, leveraging Bristow's 75 years of safety management and vertical lift operations. He participates in a variety of public speaking engagements related to advanced air mobility, operationalization, and overcoming the hype of advanced air mobility to bring it to reality. David previously served as Bristow's Executive Vice President, Chief Operating Officer, responsible for Bristow's global operations, supply chain, and IT. Prior to joining Bristow, David held positions with PHI, including President of PHI's Energy Business and PHI Americas. David started new carrier businesses for PHI in Australia, Cyprus, Ghana, Saudi Arabia, and Trinidad. He also led PHI's acquisition of Helicopters New Zealand in 2017. He has held board positions with Cougar Helicopters and Heli Offshore, the global safety-focused association for the offshore helicopter industry. David spent 20 years at Sikorsky Aircraft in a variety of leadership positions, including technical support, customer service, and commercial sales. During his time with Sikorsky, David sold and delivered the first commercial S-92 model helicopter and booked over $1 billion in commercial helicopter sales. David is a veteran of the United States Marine Corps and a fellow of the Royal Aeronautical Society. Hey, David, welcome again to the Vertical Space.
My pleasure.
Okay, David, so we're going to ask the same question as we did in the beginning of the last podcast, as we do all podcasts. What is something that very few in the industry agree with you on?
A majority of the folks in this industry, the companies in this industry, don't agree with me that really cargo is the way to move first, and that pragmatic approach to it. And that's driven by the business models that have been demonstrated, the activity levels that have to happen in order to infer some of the returns that their investors are going to expect. So they're moving forward with more of a urban mobility or transportation model in and around the cities, notably what's potentially going to be happening in the Middle East, in the United Arab Emirates, with several of the different OEMs that are vertically integrated. And then also the potential with airline transfers in the New York region first. So I want them to be successful. I do. I think they're going to be faced with certain challenges. But for Bristow and for, I think, the vast majority of the theses that we've laid out is that cargo transportation will, in a business-to-business model, is the approach early to allow us to scale to the different unique business models of both regional mobility and urban mobility as we transfer through the next 5 to 10 years.
David, how is that controversial? I think a lot of people that I speak with would say cargo is likely to be one of the first. How would well-informed people disagree with you?
It's the numbers of aircraft and the volume. It's going to be relative to the top line of the company, where cargo transportation can be smaller and profitable, but it won't drive the higher levels of revenue that has been expressed in a number of different business models.
So, David, you are the first to return as a Vertical Space podcast guest, and there's a couple of reasons that you are the first person to return. One is to discuss your new guide, the Philosophical Guide for Early Advanced Air Mobility Operations. And number two, let's face it, there are not many people who have led the community like you have with partnering with an awful lot of very prestigious organizations who are leading the way in advanced air mobility. So to be able to hear your thoughts expressed in the guide, but also expressed in what you've seen over the last couple of years and what's changed. That's probably one of the most important things. What's changed?
Yeah.
So if you could, just give us a little bit of an overview of the guide, an executive summary, because everybody should read it, but give us an executive summary of the guide.
I'll do my best. First, I think I should probably outline why I decided to write the guide. It's somewhat unique in doing so. And when I was talking to some of the executives within Bristow while I was doing this, they first of all, they were like, "What are you doing here? Are we going to lean into some of our intellectual property? Are we going to tell people exactly what to do and generate more competition?" My response is that our stated vision is to be a leader in innovative and sustainable vertical flight solutions. And being a leader really means rising other people up as well and being part of the process. So our core competencies is one of the values that we believe that Bristow brings to the advanced air mobility space. And without divulging some of the secret sauces that we use to manage our core competencies, I wanted to express the philosophies that we use and that we've learned over the 75 years of operating helicopters and airplanes to this industry and why. And so that was part of it. The other is I outlined some observations that I've made, and those are concerns. So there's these observations that I've made that are outlined in the guide, and I wanted to express that and then offer some potential solutions or at least thoughts on solutions. And the third part is really intersected the other two to be the impetus to get me to write down this was I work with an executive coach. I have for a decade. And I was discussing with him the thoughts of what we're doing, the thoughts, some of the challenges we're facing, some of the frustrations that I have in trying to relay the messaging that I want to get across in a very short time period, generally that we have with whether we're working with governments or business people or investors. You get 15 or 20 minutes. It's hard to get a very complex thought process or complex philosophy across in that. And he said, well, you're basically writing the book on this. And then he went, that's what you should do. You should write the book. So I laughed and said, I'm a busy man. I don't have time necessarily to write something that's as complex as this and that would be as in detailed. He encouraged me to use a ghostwriter, and I thought about that a little bit further. One of the things that I like to do when I'm on holiday are go on very long multi-day hikes. So last summer I was on a hike in Spain and I had a few days to really think about it. And I put the outline in my brain and jotted it down and decided to write it myself over the Christmas holidays. And so those were the three real factors there. And then I wanted to lean on people that I work with and people that I've talked to, people that I respect that have maybe a different viewpoint of whether it's aircraft certification or government relations or the real technical aspects of the advanced mobility space. So I leaned on a lot of people, three I mentioned as contributing editors, and they had a real big input to what you finally got to read. Richard Lapin is an expert in government relations and international relations, and he's worked with various governments around the world. Mark Poland is an old colleague of mine. He retired from Sikorsky a number of years ago. He was one of the first, if not the first, program manager on the S-92 and brought that aircraft through certification and launch of commercialization. And then Dr. James Wang, the professor at a university in Singapore, he built the first tilt rotor eVTOL aircraft, Project Zero, in 2011, which he showed me back then. So I was able to really lean on them and bring some of their concepts and ideas and thought processes in. And I felt like once we had it written in a draft format, it was something that a lot of people could utilize. And I didn't write it for technical experts, and I didn't write it for necessarily the people that are deeply involved in advanced mobility. But this ecosystem is going to be very large. There are going to be a lot of people that have never worked in air transportation or transportation in general. There are going to be a lot of investors that are going to be thinking about coming into this space because the total available market is substantial. And it's going to spread across the globe. There's going to be a number of hundreds of different companies that are going to start up. So the thought is we've got this great philosophy about how to bring aircraft into service and the things you need to think about specifically in vertical aviation. And hence I jotted it all down. And it's really 40 years of my experience and others.
As you read the guide, you can hear a couple of themes that are loud and clear. One is there was a lot of exuberance early on. And there was a lot of promise early on. And that in some ways, your guide is a de-risking guide, isn't it? Here's a way to de-risk your investment. Here's a way to de-risk if you're an OEM. So give us a couple of the areas that you think somebody reading the guide would perhaps think differently than where they are today, whether they be the OEM or whether they be an operator, whether they be experienced in vertical lift or not.
Well, one of the things I hope to get across in this was that once these aircraft are type certified by an airworthiness regulator, that's not the end. We don't just, now we have an aircraft that's certified and produced, it goes to a dealership or it goes into the market and we just turn them on like we do an automobile. To operate these aircraft for hire, for service, or to provide service to the public or governments, you're an airline. So recognize that. And that stems from, I presented to a Smart Cities conference a couple of years ago. And these are mega cities, very, very smart people that are driving city planning with tens of millions of people in population with lots of different infrastructure and logistics issues to deal with. And one of the comments that they came up with was that this is just like buying an electric scooter or an electric car. I'm just going to put it into service. And when I explained to them what's necessary to do that, it's you're an airline and you have to abide by the rules and regulations that drive the air transportation system. So that's one. The other is that it's not easy. So being an air carrier is not just I buy the best stuff or the best aircraft and I put it into service, and I hired it. There's so much more that goes into the thought processes of not just which aircraft you buy, but how you configure it for its purpose. What are the process and procedures that you're going to utilize for the missions that you've outlined for your business plan? And how do you impart your culture of safety throughout the entire organization? So that's a very difficult process. It's relatively easy to buy an aircraft. It takes capital. A lot of people can raise capital. It's a little harder to write process and procedures, but you can hire some of that too. So you can hire some experts and you can get a lot of things just right off the shelf. The hard bit is having a culture that at the very top of the leadership, which I believe in most, if not all cases, leaders of organizations want everybody in their organization to be safe. How you manage that and how you make that happen is a little bit more difficult than just wanting it. So you got to have it in your DNA. You've got to have it in the way that you lead, the way you present yourself and the rest of the leadership team throughout the organization. Because at the top, people want to be safe. Leadership wants to be safe. And at the line level, they're the ones that are executing. They're the ones that are going to cut their fingers. They're the ones that are going to trip and fall. They're the ones that are going to get hurt. They obviously want to be safe too. It's in the middle where you have this drive. It's if you could see like an hourglass where you're driving people for execution, you're driving people for profitability, you're driving people to meet schedules. How do you make sure that they're imparting the philosophies and beliefs of that company? That's the hard bit. So it's not just I snap my fingers, I buy an aircraft, I get an air operating certificate, and I'm ready to go. There's so much more to it. And I believe, and what I impart in this philosophical guide is that companies like Bristow, not necessarily has to be Bristow, but companies that have this experience over the years and have done it over time can put these aircraft into service in a very limited case and share the information of operational inefficiencies or data or technical problems with the industry to help improve the safety. At the same time, we're demonstrating to the regulator safe, efficient operations that will allow the expansion of into different businesses. And hopefully at the same time, we're proving out to the public where there's been certainly some disarray, if you will, if you think about the issues that Volocopter has been faced with in Paris and really the citizens not wanting that to be operated during the Olympics or in the city at all. We can turn this into a more normal mode of transportation through that process. And that will allow investors and entrepreneurs to either invest in companies or raise the capital necessary with the data that's been produced by these early operations to allow this expansion of the industry.
On the topic of all the steps that an air carrier needs to go through in order to introduce a new type to their operations, in your guide, you mentioned that can take between 12 to 18 months, everything inclusive of training, supply chain planning, writing of the operating manuals, maintenance planning, et cetera, et cetera. To what extent can this be parallelized? Talk a little bit more how that integrates with the discussions that you're having with OEMs, and to what extent is this really a serial operation as opposed to parallel?
I'll speak to the two categories. One is if we were buying a traditional aircraft that's already been type certified and in service, where that's very much a parallel operation. Say you decide to buy a new type of aircraft for your operation. They've produced it before. You're running the training organization. You're writing of the manuals. You have known performance to deal with. So you can write that in parallel with it. For an aircraft that's not yet been type certified, it's a little more challenging because there could be some constraints that appear before certification process. And there also could be some regulatory shifts or training shifts in how you're going to operate. So you try to run that in parallel as much as possible. One, to align with the allocation of capital to buy the aircraft, and two, to speed up the in-service time. But there's likely going to be a lag. So it's going to run somewhat in parallel and somewhat in series for the early adoption. And one of the things I mentioned in the document is, and this is from experience, early adopters with the wherewithal, with the financial capability to withstand and be resilient to certain aspects, the capital that's being employed, potentially with some alternative solutions in case there's a problem. We tend to have a little bit more patience with an OEM and a regulator when we're challenged with different problems, whether it's a technical problem, a regulatory problem, something that's cropped up in the operations. So you got to be able to work within that whole process. And that can, in part, can actually slow training down. It could slow the aspect of staying current with that particular aircraft if you have a gap in operations for a month or two. So all those things you'll have to deal with in the early operations side of things. So if you build a business model to just go out full throttle straight away, every aircraft flies every day, we're not going to have any issues. I mean, you're really setting yourself up for some disappointment and potential issues.
A good chunk of the document also covered your thoughts on early operations. Can we spend some time talking about how your current view on early operations has changed over the years and how you see the evolution of these early markets?
So back to the pragmatic approach. That's why I want to do something in a constrained environment with business to business operation, because one of the unique aspects of these vehicles, specifically the 100% battery electric aircraft, that's certainly nothing that we have to deal with. A traditionally powered aircraft is will likely take off at maximum or close to maximum gross takeoff weight to get the most performance we can out of these vehicles. We're also going to land at maximum gross takeoff weight, whereas traditional aircraft will be landing at a lighter weight because you've burned off the fuel, all those things. So that means we're really putting the maximum stresses on the aircraft at both takeoff and landing. The business models and the range capabilities of these vehicles are going to require multiple takeoff and landings a day. And so we don't understand purely through the certification, there'll be analysis that's done and there will be margins put on the structural integrity of it. But I do think that we'll likely see issues that will hopefully be rectifiable that we'll have to deal with on the structural side of things. I relate back to experience with traditional helicopters. As I reflected, I couldn't think of one aircraft that we put into service early that did not have some sort of a structural issue that we had to deal with, whether it's sponsons and landing gears or the frames around the primary drive system, engine mounts. You tend to have higher use cases and higher vibration messages in operations than you would in flight test. And you might not see them in flight test. You may not have predicted that these things can happen, but they tend to happen in these different environments. So having that temperate environment with average temperatures, moderate humidity, not a lot of rain and thunder and lightning, or those early operations will allow for that testing. And as we put them in harsher environments, we're going to see other issues that are going to crop up with these machines and how we deal with them and how we have the resilience and wherewithal to deal with them and ensure that we have a business model that can withstand the financial challenges that are going to be faced with.
Right. One of the things that stood out, part of your thesis, is that early operations should be over low population, low density airspace type of geographies. And just to make the conversation a little bit more interesting and spicy here, I'm going to poke some holes, but
Okay.
intuitively, this makes sense. But at the same time, the regulator will not allow a new type to fly unless they are convinced that the aircraft is safe to be integrated into the national airspace system and safe to be flown over whatever geography it is approved to fly over. And so, to make an analogy, when Boeing or Airbus introduce a new airplane, they don't have a restriction as to what airports they can be flown in and out of. Now, granted, those are systems that are well understood, and we have decades of operational data to understand them. But at the same time, it just feels like this constraint of early operations might impose some economic penalties early in the use cases where those are needed the most.
I had a sense that this was going to raise some controversy. And the hypothesis is really around several different ideas. And it's not just about the concern over safety of that operation, the concern that you may have to land the aircraft in an unplanned environment. That is part of it, but it's not all of it. The other part of our business model thesis is that these vehicles early on should provide services and goods to services to areas that are in need of it, that have poor road systems, poor transportation systems, that need to have materials brought to them in a more efficient manner. So when I think about those environments, I'll give you a couple of examples. Scandinavia has geographical barriers, so you have a lot of fjords. You have great road systems but they take lots of time to get to. You have some transportation on rail, but not a vast majority like you have in most of Central and Western Europe. And then there's places such as the northern territories of Australia. There's places within continental United States that fit that as well, and others. And those also tend to be, and it may not seem intuitive, but the coastal areas of Scandinavia is somewhat temperate. We have very few icing days. It's close to our supply chain. So that was one of the reasons behind it is that we think that there's a really good economic business model for that particular mission. And it serves the purpose of isolating the system in case there is an issue, we can deal with it. So it wasn't just about trying to put a constraint around use case of these machines. It was really our philosophy that we had stated very early that we think is the right business case for it, whether it's the islands of Scotland or fjords of Norway, or pick another country that has similar characteristics. I think Japan's another really good example. Even though you've got a great rail system, you've got a condensed population with very mountainous region with lots of rugged coastline that needs to be supported.
Do you mind sharing maybe some details when you looked at some of these use cases in terms of the size of this market opportunity, how that compares to the initial expectation of these aircraft being used for the commuter market? What's their relative size, and can OEMs really scale as expected in those early use cases?
Well, the latter part of your point is, I think, important to note because the scaling is, I believe, is not going to be at the peak levels that we're talking about early. So the production levels, I believe, they're not going to hit some of the early projections. It's going to be in the 25 to 100 to 150 aircraft per year until you scale new production, and you have to distribute the production facilities globally if you plan to penetrate those markets. So we've done. I got to be careful what I say here. There's a lot of work that's being done. A lot of it's being done under a non-disclosure agreement. But what we're looking at for these different regions in Scandinavia is potentially up to 50 aircraft in service over a 2-year period that can generate. You can do the same math that some of the SPACs have done it on. There's potential 2 to 3 million revenue per aircraft in that space. Not all of them will work every day. It is a nice market. It is a market that's potentially could provide very good returns to the operator and the other people that are investors in that process, and will provide the necessary data for the scaling, both in production and implementation into different mobility factors, whether it's regional passenger carrying and or into the urban side of things. So the other part of that aspect with this early adoption of cargo transportation is you're utilizing existing infrastructure. So there's not necessarily a requirement to go out and invest heavily in concrete or heavily in ground facilities. There will be investments that will be necessary in the charging networks that'll have to be put in place. There'll be some other investments in there as well with ground handling equipment and tooling, but not to the scale of having to build a $25 or $30 million vertiport and going through the whole process of the real estate investments that are necessary for it early on. If it works, if these aircraft are viable, safe, efficient, and reliable, that will provide the data for the investment thesis that are going to be necessary for the substantial amount of capital that's going to have to flow into the investment of infrastructure, real estate development, air traffic management, communication systems, all the things that are necessary. And then the other reason for the remoteness side of it is many of the big airports in the big cities, they're very close or at capacity. So you'll hear things from certain city planners or airport planners. It's like, oh, great, we'd love to have UAM in here, but just don't add any more airplanes to my system. I can't handle it. Whereas in these remote locations, you've got airports that are screaming for help, that want this to come in so they can actually build out a process which should potentially create new jobs.
So Dave, if we take this Scandinavian network as an example, what would you see the utilization of those 50 aircraft in that network being, and how would it compare to what has been circulated in the community as to the urban air mobility or the airport transfer use case? How do those compare to each other, and what are the pros and cons in your mind?
Some of the work that is cargo movements are in belly cargo today, so they're somewhat constrained by whatever the capacity of the aircraft is, depending on how many passengers they're utilizing and what the payload available is, and then, of course, the commercial schedule. And then the other aspect is you're replacing lorries and trucks, depending on which part of the world you're in. As far as utilization goes, so analysis is done. At this point in time, it's a guess. What are we going to get for reliability? What's the backup requirements? What's the maintenance schedule? We don't know those information yet. If you look at it, a helicopter operation, the maximum utilization we tend to get on a per tail number or per sail number aircraft is about 90%. You say take a 12-hour day, 90% of the time we can get a helicopter going. To get to a higher utilization, you have to employ more capital and have additional assets in place for backups. In the helicopter world, it's a much more intense amount of capital than you see in fixed wing aircraft. So, it's not. I think it's not unusual for a company, ultra low cost carrier with hundreds of aircraft, that maybe have 3 or 4 backups. I don't know what the big carriers carry. So to get to that rate will take more capital, and that's what we'll be planning in a certain number of technical backups to support maintenance operations and downtime for technical capabilities. And what we've learned in the helicopter operation is that with the proper amount of technical backup, we can get up to 99% utilization rate. And then that's measuring dispatch utilization. And then now you got to talk about what's the utilization of the payload capabilities of the asset.
And the number of flights,
and
for
the
instance,
number of flights, and really that's going to be relative to the performance of the aircraft, the hazards which you need to mitigate. We're again just building early schedules out, but we're thinking about 6 hours of operation on a daily basis is about the right way to start, somewhere between 6 and 8 hours. So you're taking into account whether you have to have additional crew, fatigue risk management, the turnaround time, what you have to download, if there's information to be downloaded, the charging side of things. There's 6 to 8 hours of daily utilization should suffice.
So in the absence of operational data, where do you find the basis to ground your assumptions as to the level of interest and how you prioritize these early use cases?
Well, you want to go somewhat of the art of war, go where your enemy's not, or go where it's easy to penetrate the market. So there are certain just jurisdictions in the world that are willing to work with what they might call a sandbox operation to prove some of these theses out. So potentially taking aircraft, even in a pre-certification role, in a limited case of scope, and doing actual commercial operations for it. So proving out that process, getting potentially some PSO routes and some other things that could help support the economics of it. And then there's the sustainability aspect, and then potentially the economic aspect. And I think, sorry, to go back to one of your first questions about what other people don't agree on, is that a lot of people are pushing the sustainability side, and it's very important. But the economic model and the cost structure of this has to work first. Otherwise, it's going to be a difficult process. So that's the grounding of it. So I've spent a lot of time, and my colleagues have spent a lot of time working within different networks in government, working with different airport authorities and different logistics companies and energy and industrial companies that are really keen to give this a try and see if it works. And that's why, again, back to the earlier show, invest as little capital as possible, do it with an operation that has existing infrastructure to prove it out so we can scale.
Do you feel that you've properly expressed your 5-point thesis? We've nibbled at it, but if you could just rattle off the 5s.
Okay. So my 5 theses are that early stage AAM operations should focus on a business to business model, a commercial model that support a logistics network that's potentially already in place, and that you do that within in a 20 to 60 kilometer range. That's the first part. Second thesis is that advanced air mobility commercial operations will be required to be conducted by a licensed air carrier. So you're effectively an airline. And particularly in the early stages, our thesis is that airline should have some experience in vertical lift and in safety management to be the most efficient to doing so. Third thesis is that early stage AAM operations are best conducted by companies experienced in purchasing and configuring aircraft for their intended uses. AAM manufacturers would be best advised to work with these companies to ensure that the product that they're developing is commercially viable and will be able to be used by the use cases. And the genesis of that thesis is that there would be equipment and use cases that are necessary that don't necessarily need to be part of a type certification. So aircraft that are type certified don't necessarily have to have an enhanced ground proximity warning system or a TCAS, but they're certainly needed for fit for purpose for certain operations. And then fourth thesis is early AAM operations should be conducted by air carriers using existing infrastructure with a willingness to collaborate with potentially new companies in order to share data that is not necessarily commercial, but operational and safety to allow the AAM business to scale on a global basis. And that fifth thesis is that air carriers involved in AAM operations should have the appropriate equipment, processes, programs, and people in place to manage both the health and flight data that we're going to derive from these vehicles. And that in part will also allow a shorter time scale to do some of these early testings that I philosophize around. So learning that process of having more data than we ever had on any other aircraft will allow us to crunch that data, aggregate it, and understand the health of the vehicle in a much faster pace than we would have if we had just had an analog aircraft and starting it out. So I think that by utilizing that data, you could accelerate into different and newer commercial models that will potentially substantiate some of the financial theses that have been put forward.
Dave, so you lay out the rationale for these theses in the document, but if you were to sum it up for the audience, what is the theme running in the background through your thinking that led you to create these theses? I mean, it strikes me as an approach that is grounded in a more realistic and experienced view of what operations are actually like and brings that into the conversation. But in your words, what are the underlying themes behind your conclusions that you create in these points?
So I want to say that I'm absolutely optimistic about advanced air mobility and all the potential use cases of it. And I believe that optimism is a force multiplier. So I want to get that out, Chris, because there is certainly a grounding. And some people could see this as pessimistic, or some people could say this as have a poor view of some of the early operations that may occur outside of my theses. So I'm very optimistic about it. But behind it is something that I talked about early on is we're at a revolutionary point in aerospace. This technology of distributed electric propulsion systems and advanced flight control systems is revolutionary. And we must apply the evolutionary learnings that we have had over the last 120 years. And by doing so, in the thesis I lay out, you're helping to ground that base and think about, okay, let's not just run down the hill. Let's walk and make sure that we can cover all the aspects that we need to cover. Our air transportation industry is the safest mode of transportation in the world. And yet we still have some certainly surprises that occur in aviation safety, in the design of the vehicles, in the control systems. We've all seen them in recent times. And here, these are processes in aircraft that have been around for quite some time. So I just want to make sure that we stay grounded in that. We don't just accept the fact that we got this new technology and it's going to just work immediately and be safe because it's new tech. We've got to go through the processes and procedures and time of use to bring this to a scalable solution for transportation.
David, in some ways, you're very blatant about it in your guide, but what you're basically saying is bringing technology to aviation is hard.
Yeah, it's super hard.
And for those of you who, I'm putting a little bit of a shameless plug in for our companies, because this is one of the things we understand, and this is how we help our customers. But it's hard. And for those of you who have not worked in bringing technology to market in aviation, there are so many hurdles that you can't anticipate. And just because you certified your plane, you have so many other things to consider.
Yep.
We all read what we want to read, right?
Yeah.
But that really popped out from your guide.
Well, thanks. I mean, that's really the gist of it. It is hard. What every one of these entrepreneurs and designers and the OEMs are doing is super hard. Getting an aircraft to type certification, super hard, super expensive. And now you've got an aircraft type certified that you've been thinking about for 5 or 6 years, been working on getting it designed, and the technology is advancing beyond your certification base. So you've got to work on catching that back up and this loop there. And then now you got it type certified. Now you got to build it. You got to build it in a manner that's reflective of the type certification in a repeatable way, in a high quality way, which takes another couple $100 million to build out a facility to get to the production levels that are going to be necessary for this to scale. And I think it's brilliant that many of these companies are leaning on automotive because I do think that that's what this is going to look like long-term production. But building aircraft on an automotive model, it's a different way of things. And I was sharing a story today with one of the OEMs about an aircraft that's been in our. This aircraft, this is public information. We had an accident of an aircraft 2 years ago, about a year and a half ago, actually. And what it was an installation defect that happened 11 years ago. The aircraft's been in service for 11 years, and the defect finally materialized. And if not for the great coordination of our air crew, it would have been a very catastrophic event. But the team was able to analyze what had occurred and manage the process and land the aircraft safely, albeit with a little bit of damage. So these are just, it's really hard stuff. And getting to repeat on a large scale of aircraft production, a helicopter manufacturer today, on a very good year, is doing maybe 50 to 60 aircraft a year. We're talking about that in a month now, or even more at scale. So how do you ensure that repetitiveness? How do you ensure that quality system throughout the hundreds of people that are going to, or even the people that be programming the robots to install it? All that's going to be a big challenge. So now you got to produce, and then you got to get an airworthiness certificate on and get it to an operator or operate it yourself, which also lends itself to a very difficult process. One, to convince yourself, safe, efficient, reliable, convince your local regulator so you can get it on your operation specifications, and ensure you have the aircraft fit for purpose to meet the mission and the environment that you want to run your commercial program on.
Okay, so based on these observations, what do you think about the aircraft OEMs that want to have that vertically integrated business model and also be the operator? What are the pros, cons, or implications of your observations on that path forward for a company?
So it's going to take a lot of capital. My first view, it's going to take a tremendous amount of capital. It's going to take more capital than they would have if they were going to be a traditional OEM. And it's another step that's harder. So if you're a traditional OEM, you're part of potentially two processes: type certification, support of that type certificate, and production. And now you're adding back in the third portion of the difficult processes of operating it and the complexities. And the core competencies to operate and build are very, very different. I understand why some of the companies want to do it, specifically in the United States. And I believe that their business model makes sense to them. And I think they're going to be successful early on. And I want them to be successful early on. I've had discussions with both of them that are in a more vertical mode. Their success is going to hinge on a lot of the future successes of this industry, because they'll be some of the early adopters. I do think it's a challenge to the business model, and that they may have to shift some of their thinking. And I think you're seeing some of that with each of them doing more international sales and partnering with a variety of different organizations. But then in the other cases, you're somewhat of an homogenous society, if you think about it in that way, where you're the entire ecosystem and you have control of that, but you're also the entire ecosystem. When something goes wrong, your complete economic model shuts down, no matter where you are in that process. So if you have a technical problem that you have to deal with over a certain period of times, both your production is in disarray or could be in jeopardy, and you're not flying. So you're not collecting any revenue at all. And there's no alternative for you because you don't have a different sources of transportation. Whereas traditional operators such as ours, one of the reasons we have a variety of different partnerships with the OEMs is it's our experience that we will have technical problems and we will need to use alternative aircraft that may not be the most fit for one when there's other problems with those vehicles. So there's certainly that risk associated with it. That's what I see. But I do think that they've raised enough capital and that they can get through this process and get the aircraft into their operation. And I understand their process of doing so. And there's an argument that controlling the whole ecosystem under one management team could be safer, and you're controlling your brand in a better way. So I understand that.
And also vertically integrating at this stage of the life of this new market gives you the opportunity to learn faster and absorb the lessons learned from operations into next generation of aircraft
Precisely.
and product iterations.
Yeah. But to broaden your market, it's going to take a tremendous more amount of capital to do so.
Right.
But
David, I'm sure that somebody reading the guide might say, look, this really sounds like an incumbent that is trying to protect their position when faced with a wave of new entrants. right? Because throughout the document, there are hints at how only current established air carriers have the experience and the wherewithal and the competencies to pull this off and introduce these new aircraft. And so, one thing that stood out as I was reading it is your comment that no matter how dedicated to the concept of mission, a company cannot set policies and fully understand and manage the risk and assurance of running air operations. This is a quote.
Yeah.
Without the experience that comes from being an air carrier. So, what does that say about the landscape of emerging air carriers? Are you making a statement that all the future air carriers for these vehicles already exist today?
No, I'm
Is it
not.
reasonable to
It's actually
expect new entrants? How is that going to play out?
absolutely reasonable and expected and required, because we can't all operate in across the globe. So you're a regional air carrier. Bristow itself is a global regional air carrier. We operate in 17 countries. 17 is all, right? There's a lot more countries in the world than 17, where they'll have all their own regulations. They're going to need their own startup companies. They're going to need their own processes and procedures to do this. My thesis is that they can learn from us, and we are willing to share that information and collaborate to allow this to scale globally. The thesis is we think that it's best to start with us, and this information can be disseminated quickly because we'll have so much data from the health of the aircraft and the flight data, and potentially some of the business constraints that we'll have to deal with to allow that scaling on a global basis. So that's why I say in one of the theses, they must be willing to collaborate. So this is really a thing. We want to be a leader. We want to be a leader because we want a great business. We also want to be a leader because we think this is necessary for the sustainability of transportation. It's necessary for this new revolution of aerospace and technologies that are being applied. We think that we start with these eVTOLs, we start with these STOLs, and that the propulsion systems and the power systems and the energy sources are going to get us to a point where this is a much broader transportation network. We can put it on a larger equipment, potentially even transatlantic flights someday or trans-Pacific intercontinental flights someday. So it starts here, and companies like ours with that experience can help get that started. That's the thesis behind it. And there's plenty of really great people out there that have that experience that can move around the companies or can come in and help with that technology for those startups as well. That it's not just that you have to be the company, but that team that you put together will need that experience or the lessons learned. And we think that's one of our duties to this industry.
David, as people have reviewed the guide for you before you published it, what's been some of the tougher questions they've asked you or the challenges you've heard on the guide that you'd want to share with the audience?
Well, we spent 2 weeks deciding whether takeoff was a noun or an adjective with a preposition.
Okay.
So you can imagine who
Right.
that was with.
Right.
Well, some of the review is exactly what some of the points that you've put out, specifically, Luke. Are you just trying to ring fence this business? I mean, this is going to be so large. The total market, if successful early, is massive, and there's no way that we would even want to ring fence that. So we think we can create our business on our attributes, and that we think that we should help things. So there was that concern of the ring fencing. There was a tremendous amount of debate about. I did use some stronger languages in some of the early drafts about should or must or shall and must. So that some of that came out. We got a little bit more detailed in the types of advanced air mobility aircraft, laying that out. I was a little concerned about being too technical. And then there's been a really great reception of the portions on safety management and data collection and how it's aggregated. I had a fireside chat at the Revolutionary conference today. There was quite a few questions about what the data should look like, who owns it, how does it work, how would you manage it, and my words were, if an OEM or a major supplier that's managing the aircraft data doesn't want to share that information and aggregate it and work with the operators to ensure that we set appropriate thresholds, that we have algorithms to detect anomalies that we learn, and that we have actions that come out of these measurements, then we're not really interested in working with those organizations. So back to collaboration, I think we all have to collaborate to get this started and get it going as an ecosystem and a transportation network to allow it to grow, to really garnish the benefits that we all hope it can provide the world.
David, real quickly on the aviation safety data. Yeah, a lot of emphasis on that, on the sharing of the data, which you would expect, and also a fair amount of discussion on what I'll call FOQA data. We had Andrew Coleman on from GE recently. So I was a little surprised by it. Now, on the aviation data side, safety sharing side, we all know that 20 plus years ago, a huge advancement in aviation safety occurred because of the sharing of the data.
Yes.
How is what you're recommending any different than what we see on the commercial side today? Or is it almost identical and you're taking the lessons learned from what's occurred in the last 20, 30 years?
Taking the lessons learned in the last 20 or 30 years, taking the work that the organizations that we've built in heli offshore, I want to apply that. And the epiphany I had on that was because we're starting this organization, AAM Safety Consortium, is that heli offshore was founded in 2014. So we've been operating helicopters for 70 years, 60, 70 years. And we finally got around to putting a proper organization together to manage that. And speaking with the gentleman who runs heli offshore, and I was a former board member of heli offshore, if we had a chance to start at the very beginning, just imagine what we could have accomplished. So here's an opportunity. We have a clean sheet of paper. We have a very good template. And even recently, the Royal Aeronautical Society published a paper of kind of 3 issues that could potentially happen. They outlined pseudo accidents and what could occur. And they even mentioned the fact that having an organization such as heli offshore will help mitigate potential issues and accidents. That we have that information. Somebody has that information. It needs to be shared, because we're going to see different problems across the globe. You'll have, and you may even see similar problems. For instance, an inspector's out there looking at an aircraft. They notice there's something wrong with the propeller, and it's delaminated, and it's delaminated in this section. That message can go out to all the operators very quickly, and they can simply just go out and check.
Just as we see on the commercial side today.
Yeah, and so yeah.
Do you feel this message has to be said to some? Are some not listening, whether they be OEMs or future operators? Or do you generally see that the industry is in agreement that this has to be done, regardless of the organization that's pulling it together?
I'd say it's 64-40 that really it hasn't either, not that they're against it, but I don't think they've embraced it or understand it.
Why would they not?
Probably a fear of sharing information. That was always a big challenge, and it continues to be so. And what you find in these organizations is, let's say you have an organization of 100 people in it, 20 of them are doing all the work, 80 of them are resting on the other 20%. So a lot of the information that flows comes from a smaller group. And then there's also somewhat of a fear of sharing information that may harm you commercially. So you have to get past that. You can do it with proper contracts and agreements, but everybody needs to operate in this case in good faith. And safety is an industry-wide concern, and it should be focused on as an industry, not just as an individual company.
And those are some of the same hurdles we heard 20, 25 years ago with sharing safety data, and some of the same hurdles we heard Lauren Cass mentioned in sharing swim data 20 years ago. And people eventually get over it. But when it comes to safety, you would think it'd be close to 100%. And if it's not today, it will be a year from now.
Well, some people aren't willing to recognize that they may have a problem. But we're not going to have a technical problem. My aircraft's perfect. I'm sure there's some of that.
And then the second part is FOQA data. How will the FOQA-like data be any different than how commercial organizations, 121s and the others, are using it today? Or do you see it identical to, for example, what GE's doing?
I mean, the technical component of FOQA, identical. The impact, I think, will be greater in this environment. One, the numbers of aircraft will be substantially more. These are aircraft that are primarily going to be flown VFR in low altitude space. So it's going to be having that assurance that the aircraft are being operated as the operation specifications and the company wants it to be operated in. I think it's going to have a greater impact on the industry. And then also, it's interesting, you think about health and usage systems as a way to mitigate certain cost structures and improve the product reliability. But FOQA also comes into play here, where you may see, even though it's within the specifications of the aircraft or maybe within the operation specifications, you may see some use cases where you're wearing out wheels and brakes. And one base may be wearing out wheels and brakes at a higher pace than another. And when you look at Folkwall, you can determine what's happening and potentially mitigate that. So there's some really interesting, and this is an experience that I've had, is there's some interesting economic benefits beyond just the assurance that the aircraft is being operated in a safe manner. And it's going to be also very important to play back into the training organization. And with the technologies we have today to replay in simulators and to replay in three-dimensional models, it's going to help the new line pilots and the new engineers coming into play to learn some of the lessons learned and see actual flights that have transpired. But it's also vital that FOQA is non-punitive unless there was a willful misconduct.
Oh, sure. David, given your guide, given you learned over the last couple of years, what would you have done differently at Bristow? And what organizations perhaps would you have said, maybe I wouldn't have done something with this vehicle type, then based on what you've learned?
Yeah, I think one, coming in a little earlier than we did would have helped. We are, I think, an early adopter, but on the scale of things, a lot was happening pre the merger of Bristow, so we really couldn't have done it. But there was quite a bit of work that had been done with the pre-merger era team, mostly data collection and some discussion. So getting in earlier, maybe applying more human resources to it. We wanted to be very careful in nascent business. We still, especially in 2021, weren't sure what this was going to look like. There was a tremendous amount of capital flowing in. So I think applying a little bit more resource to it, I think would have perhaps accelerated our processes. The latter part of your question, I'm very pleased with all the companies that we've dealt with. It's difficult right now because there's really some other interesting products that are being developed and some interesting entrepreneurs that I just have to say to them, it's not you, it's me. We are at our capacity of our team. We're a very small team by design, which allowed us to be somewhat flexible. So having a little more resources could potentially have allowed us into different markets. The other aspect, and this was a question from the first discussion we had, because there was a lot of discussion about the drone market, maybe entering or thinking about that a little bit more on a scaled basis. I still believe that for us to start a commercial drone business on our own is going to be difficult because of the nature of our cost structure and the size of our business and the flexibility that small startups will have. They'll have the advantage there in the cost structure, but working in a better way with some of the leaders in drones and cargo delivery on the drone side, I think would have been something that. But we're somewhat into it now. There's been a partnership made with one of the big players that I'm really proud of. We're going to be doing some work with them, proving out certain operations and potentially doing concept of operations for the Port Authority of New York and New Jersey.
I'm glad you raised this because I was going to ask you how an organization like Bristow might think about using UAS of various payload capacities from a couple 100 pounds to maybe a couple tons even to execute on the mission like you described in Scandinavia or Northern Australia.
Yeah.
And thinking a little bit differently about the movement of cargo in general that's optimized with these kinds of vehicles in mind that are cheaper to operate.
Yes. Well, we certainly are thinking about that, and that's in our portfolio with Elroy Air Chaparral. You have a vehicle hybrid electric system, automatic loading and unloading of the payload, the pod, capabilities of putting different payloads into the pod, including surveillance equipment and things that are necessary for coastal surveillance or whatever you happen to be doing. And doing those operations, as you mentioned, in places like Australia, Alaska, and Norway. There's an energy company in Norway that's been testing out some operations beyond visual line of sight, long distance. They want a 200-kilo payload to support their energy business to hotshot parts out. They've done the economic model and they understand what being able to get those parts in a fashion they can with a drone versus a helicopter or a boat, which is most cases they use, and they can increase the uptime of their rigs materially. We're talking millions of dollars a month of change of production earnings or cost shutdown issues that they deal with. But that's absolutely our business thesis of using those size drones for that. When I was talking about the littler ones.
What are those conversations like internally? What are the considerations when you think about adopting something that is a bit of a departure from your core competence? As you enter that gray zone, what are you comfortable? What do you fear the most? Shine some light to our audience about those boardroom level discussions.
Some are at the boardroom and some are really at the operational level. So as I mentioned earlier, we do operate drones for His Majesty's Coast Guard, but that isn't a government organization. It's not a type certified aircraft. It's not a commercial license to do it because we can do it for public service. Operated piloted aircraft, we do that. We understand it. We know how to do it. We've got licenses to do it. Going into a remotely piloted aircraft beyond visual line of sight, which we have core competencies in that business, but translating that into a commercial side is something that's not necessarily one of our core competencies. So what the fear is, what would it cost? How long would it take? Should we partner with another organization that has some of those core competencies already, and we could help some of their weaknesses that they may have, market access, working with energy companies, sort of things. Hence an early kind of discussion with one of them that's doing that. So that's a way to mitigate it. We're still going to be measuring whether we should do it ourselves, whether we need a separate, whatever jurisdiction we have in, do you have a separate operating certificate for that, or do you put it onto your current commercial operating certificate? What are the risks associated? If you have a problem in the advanced mobility side, how would it affect the traditional helicopter model if you're on the same certificate? Do we separate that? That's all the work that we're doing today in terms of our roadmap to operations.
So when you look at that remotely piloted operation that you would be flying, how does it differ from the way the Department of Defense might be flying the same platform? I mean, you mentioned Elroy Air. Obviously, they're bringing forward a platform for both markets. But when you really get close to it, are there some major differences that sort of rise to the level of gotchas for those companies? Or are you really laying out a path that is a consistent and scalable dual use path? Because obviously DoD right now is one of the most aggressive customers for this capability.
Yes. So my answer is going to be somewhat speculative because I'm not in depth on what DoD and Elroy are working on, other than I know they're in the AvWorks process. But I will say that operating an aircraft to an oil rig or to a platform and working for an energy company comes with a lot more responsibility, a lot more requirements that they would put on that I believe that the military wouldn't necessarily apply in the general operation processes, the requirements for mitigating liability, limitations of liability, insurance processes, consequential damages. If you bang up an oil platform that's producing 10,000 barrels of oil a day, do the math. That's a pretty heavy liability. So it comes with a tremendous amount more oversight and potential responsibilities for the operation.
And just for background, when you run an operation out to an oil rig, let's say in the Gulf of Mexico, is the entire flight within the NAS, or what portion of it would be outside?
If we're flying VFR, most of the proportion beyond line of sight of the coast is not within the NAS. ADS-B out has helped us get more in, and we do quite a few more IFR flights where we're controlled. That's within the United States. So we actually have to control and set up communication networks offshore to ensure we have communication, navigation systems. We also use satellite downlinks and uploads to know position of the aircraft on a repetitive basis. It repeats about every 10 to 15 seconds. And then they'll have some push-to-talk capabilities there. So it's a bit of a mixed bag depending on the flight and the location and whether they're flying in IFR conditions or not.
I wanted to get your thoughts on how our audience should be thinking about the market size of the mission set that you are putting forward in this document as the lowest risk path for scaling up. I believe that it's big. There are billions of people living in remote areas that need things, and there are lots of different applications, but it's not as conceptually obvious to the broader audience in terms of the scale of that as compared to the story around AAM and the things that this industry has raised a lot of capital on over the last few years. So you're close to it.
Okay.
How do you communicate that? How do you get people comfortable with the scale and the timing of how quickly we can access that scale in this mission set?
Last year, we spent a tremendous amount of work looking at the scale of the market, the total available market, and then narrowing that down to what would apply to Bristow. What markets are we in today, and what is the size of that prize, and what is our right to win it? So on a total available market, and I'm going to go to this analysis that was done by a very reputable firm. By 2035, we think on the cargo market size of it is approximately 60,000 aircraft, potentially, total market globally, cargo. Same basic numbers for both urban and regional mobility side of it. So you're thinking about a potential market size of 120,000 aircraft. 2035 and beyond, maybe that's getting pushed down a little bit further. For Bristow, and back to the thesis is here, because that was the basis, some of those theses were the basis of the work that we did to narrow that market down to potential market for our company, and then what that size of the prize is and what's our right to win it. And then when we narrow it down to specific markets that meet our thesis, and this has been put in some of our public information, we've talked this with analysts, that is the industrial model. So working with our current industrial customers and potential some middle mile cargo transportation systems and logistics networks. The other part is pure regional mobility cargo transportation, supporting a network perhaps in Northern Europe and other places. And then the third is back to using our core competencies and white labeling for a large 121 carrier to provide airport transportation. So we see those as the initial markets, and within the scope of our theses, of course, industry cargo first, then moving into the potential passenger markets. We think that for Bristow, on a top line basis by 2030, 2031 is somewhere between, I got to be careful what I say here. I don't know what to put any forward-looking statements, but a sizable material market for the business on hundreds of aircraft. I mean, it is public that we have placed orders for approximately 450 odd aircraft with the different equipment manufacturers. We have put in capital now with some of those manufacturers because they've hit certain milestones in their processes. So we're on the road to doing that. We're looking at potential additional milestones met by this year. And we also believe that there's a potential that we could operate a small scale electric aircraft sometime this year or early next. And then potentially on the cargo side, early aircraft in 2025.
David, how has the market changed from 2 years ago? Gone up, gone down by what percent?
Based on the assumptions we made in 2023, it still stands. We haven't adjusted it. Yes.
What's surprised you over the last couple of years?
The change of leadership in organizations, specifically this year. There's been a number of different changes at CEO levels and other different at C-suite levels. Another thing that surprised me is I had expected more exits from the industry or consolidation. I was very pleased to see the Joby X-Wing consolidation. I'd like to potentially see more of that. There's just not enough capital that's going to be available for investment to meet the size of all the companies that are trying to enter into this market. So we're going to have to see that scale down. So I did expect more exits. I was somewhat surprised early on by Volocopter's issue with the German government not being able to get the loan guarantees. I think that as the early investors, the SPACs have been done, the private equity's coming, it's not necessarily going to be there. You're going to need more government support, specifically the European companies. Whereas in the United States, I think that the Air Force program has helped really substantiate and validate the equipment and provided a level of some revenue to support their operations. Those are the big surprises for me. I guess some people may say, are you not surprised by some of the delays in certification? I'm certainly not. We've built our models around potential aircraft moving out to the right. I also, and I said this today at Revolutionary, it's not just the aircraft certification that's going to get delayed, but in my entire history of buying aircraft and delivering aircraft as a salesperson, I can't think of too many times we actually did it on time. There are always delays. People have robust schedules. They put them in place. So you have to build that resilience. So I'm certainly not surprised by the delays. I'm encouraged by it. I've also been encouraged by the latest advisor circular that the FAA published recently that aligns more with the EASA and gives some better direction on the vehicle certification and some of the other aspects of it. So not surprised, but very happy to see that. Really changes in the organization, no consolidation, no major exits to speak of, as surprised me for sure.
What technology OEM operator has been the most significant positive surprise in the last year or so, where you said, wow, I didn't see that coming, and you're very impressed by it?
So Airbus was very coy about what they were doing with their aircraft. we're a big customer of Airbus. We've been in discussion with them. We were always getting just, yeah, we're doing something. We're not going to be really thinking about that. So finally coming out a little bit more into play, willing to make some deals with others. We've been happily surprised by Airbus's input. And on the other side of the coin, I've been surprised to not see companies like the other OEMs, Leonardo, Textron, Lockheed, really step into it in a big way. They are developing some vehicles. Lockheed is certainly, and Lockheed's an investor in a few others. But I've been surprised to not see them either make an acquisition and or announce a major development in this space.
Any change to advice you'd give to entrepreneurs that you gave in your last podcast?
Yeah, so I'd stick with picks and shovels. I would stick with that. I think that's still important. Make deals with at this point in space. If you want to get into this space, I would think about how you could be a supplier to the industry, the OEMs. And then a little later, well, in line with that, the drone deliveries and the beyond visual line of sight is accelerating. I think there's really good opportunities there for entrepreneurs that are willing to step into that space. And that's something I think you can do. And then others that are willing to maybe wait a little bit longer, infrastructure investment, infrastructure in real estate, infrastructure in communication, navigation systems, in data processing and data aggregation.
I know you've listened to a lot of our podcasts. Is there any one podcast that stands out that you like and why?
Yeah, I listen to most of them. If not, I have listened to most of them. One I find it very informative. And I always believe that you learn by listening to people that are smarter than you. And everybody on your podcast is generally smarter than me. My favorite is going to be Don Langford for personal reasons. One, I think that one is within our portfolio, one of the companies that we're really hopeful for with Electra.aero. Two, he's just a force of this industry with such a proven track record. And he's also influenced many of your other podcast people that have been on. They've either worked with him or worked for him within his team. And he's really spread his knowledge across the industry that it's difficult to replicate and absolutely necessary. So I view as somebody that I would love to be able to emulate in any way, shape, or form. So hearing him speak about not what he's doing about this AAM industry, but is what he's doing potentially for STEM operations and his investments in things to get young people interested in aviation, I think was just remarkable.
David, thanks for being on, and good journeys back.
Thank you, guys. I'm just an honor. Thanks for having me back again. I look forward to the feedback and hopefully seeing you all in person soon.
All right, that's a wrap for today. Thank you for listening to the Vertical Space Podcast. Reach out if there are topics that you would like us to discuss, and goodbye until the next episode. Unless mentioned, this podcast is in no way endorsing or promoting any person and or company mentioned, and all opinions within the podcast are solely that of the presenters. The Vertical Space makes no guarantees, warranty, or representation of any information given in this podcast. Any information given is for informational purposes and should be used at your own risk. This podcast is for general, educational, and entertainment purposes only.